Hello. So, question number one, mention applications of electromagnetic waves in engineering. Answer, imaging with electromagnetic waves by taking images. Those we are using electromagnetic waves as a source. Sensing purpose. Sensors also is based on electromagnetic waves. Electromagnetic applications in medicines. Electromagnetic waves also used in medicine for treatment of diseases. Electromagnetic waves applications in nanotechnology. Electromagnetic waves are used in preparation of nanomaterials, preparation of smart materials. Electromagnetic waves are using electromagnetic waves used in measurements. It's also used to measurement. For example, lasers they're using for measuring the material size and shape like that. Microscopes they're using the measuring the length of the cell board, cells and bacteria, microorganisms like that. Electromagnetic radiations are used in modeling of devices, circuits and circuits. Electromagnetic radiations are used in inverse scattering and inverse electromagnetic problems. Electromagnetic radiations are used in radiators, antennas, like that also they are using electromagnetic radiations. Electromagnetic radiations are used in wireless power transfer. They will pass the electromagnetic radiation and it will convert light energy into electrical energy. So that is also they are using electromagnetic in that field also they are using electromagnetic radiations. Electromagnetic radiations are used in radio frequency identifications. So this shows that electromagnetic radiations are used in communication purpose. Electromagnetic radiations are used in sensors. Electromagnetic radiations are used in biomedicines for the treatment of cancer. Electromagnetic radiations are used in disease diagnosis purpose. Electromagnetic radiations are used for the materials measurements. Electromagnetic radiations are used in identification of materials. Electromagnetic radiations are used in preparation of smart materials. Electromagnetic radiations are used in models, modeling, circuits, and electronic technology. So in these fields, electromagnetic radiations are used. We can understand from this slide. So explain, next question, explain electromagnetic spectrum and their applications. So in electromagnetic radiations, electromagnetic spectrum, it is a continuous radiation. It's containing electric field and the magnetic field. Electric field is perpendicular to magnetic field. Magnetic field is perpendicular to electric field. So electric field generate magnetic field. Magnetic field generate electric field. It is a self-propagating radiation. It is a self-propagating radiation. Itself, these radiations are continuously moving from the sunlight to the Earth's surface. Then again, it is moving back to the Earth's surface to sunlight. Though these radiations are continuous, it's containing electromagnetic radiations containing different wavelengths and frequency. If it is a wavelength is very high, we are calling that radiations, we are calling it radio waves. And then based on the wavelength, we are classified microwave radiation, infrared radiation, visible radiations, ultraviolet radiations, X-ray radiations, gamma radiations. We take a wavelength is big, radio signal will receive. You can see radio wavelength is smaller, microwave radiation. It will interact with the material. There is a rotation of atoms is takes place. If it is a material infrared radiation, this is used to vibrate the molecule. Due to the vibration of the molecule, heat is generating. There is a TV remote. We are using a infrared radiation. Visible radiations are used to glow the bulb. Visible radiations are exciting the atoms and it will produce a light. So lighting purpose also we are using visible radiation, ultraviolet radiations we are using for killing of microorganisms, bacteria, and also to kill the cancer cells. Also, UV visible radiations are using visible, that is ultraviolet radiations. We are using ultraviolet radiations, having a three ultraviolet radiation A, B, C. C is very harmful. Its wavelength is small. High energetic radiations. And then there is a following, there is a one other radiations. We see X-rays. X-rays also its wavelength is smaller and frequency is very high. And gamma radiations, radioactivity element that is producing gamma radiations are there. So in this, you can see this when you move from when we move from radio waves to microwaves, infrared radiation, visible radiation, UV, X-rays, gamma radiations. The wavelength is decreases and frequency increases, and when it is interact with materials, body, the material temperature is also increases. When you see, if you take a visible radiation, it will produce 1K. UV, it will produce 100K. And when it is a X-ray, it is interacting, there is a 10,000 K, and gamma radiation interacting, there is a 10 million K it is producing in the matter. So as I told already, there is electromagnetic radiation. It contains electric and magnetic field. Magnetic field is perpendicular to electric field. Self-propagating radiation. The speed of light in vacuum is 3 into 10 to the power of 3 into 10 to the power of 8 meter per second. So there's a speed of traveling in the matter. So we understand that electromagnetic radiation spectrum is a continuous. As the wavelength grows smaller in size, their frequency increases along with their energy. Radiation interact with the matter that is of similar size. What is the size of wavelength? Based on the size of the wavelength and material size, the interaction takes place. Explain light and matter interaction. Radiation interact with matter that is of similar size. From wavelength larger than UVC, there is UVB, UVA, visible radiations, infrared radiations, microwave radiations, radio radiations. There are four processes of interaction: transmission, reflection, scattering, and absorption. Wavelength from UVC onwards, that is UVC, X-ray, gamma radiations, can directly interact with the matter at atomic level. Ionization happens when electromagnetic radiations knocks an electron out of an atom. When gamma X-rays expel and atoms, electron removal takes place. Ionization is happen. Due to the ionization, the positive ions will create. That is unstable. It reacts with negative ion and formation of compound. Discuss the differences between photochemical and thermochemical reactions. Photochemical reactions and thermal chemical reaction. This is the photochemical reaction column. This is the thermochemical reactions column. These reactions involves absorption of light. These reactions involves of absorption of light or evolution of reduction of heat. The presence of light is the primary requirement of these reactions. The presence these reactions takes place in the dark as well as in light conditions. Thermochemical reaction temperature has very little effect on rate of thermochemical reactions. Photochemical reactions temperature has very little effect on photochemical reaction. Thermochemical reactions temperature is significant effect on thermochemical reactions. Photochemical activation is highly selective in nature. Thermochemical activation is not selective in nature. So fifth one, the formation of carbohydrates, glucose, carbon dioxide react with water in the presence of chlorophyll. The formation of carbohydrates and oxygen is the photochemical reaction. Example, formation of carbon dioxide, amine, thermal decomposition reaction. It is come under thermochemical reactions. In case of photochemical reactions, rate of reaction is rate of reaction is independent of temperature, but it depends on intensity of radiation. Rate of thermal reactions is depends on temperatures. So I guess you understand. So what is the difference means in material when material interact with the light, absorption is take place, photochemical reaction is take place. Heat interaction is take place means heat absorption takes place or production of heat is thermochemical reactions is take place. Photochemical reaction is dependent intensity of light. Thermochemical reactions is depends upon temperature. So glucose formation, oxygen formation by using carbon dioxide and water is photochemical reaction is best example. Thermal reaction is formation of carbon monoxide, carbon dioxide, amine. Decomposition reaction is coming under thermal reactions. Okay, so these are all the things mentioned the application of electromagnetic radiations engineering. Explain electromagnetic spectrum and their applications, explain light and matter interaction, discuss the differences between photochemical and thermal reactions. We have discussed. We'll stop here.